It's time to continue on in our VLAN sub-series here as we talk about in-depth trunking. I don't know why that just sounded funny to me. Sounds like something you would do on the weekend. I'm going to go trunking this weekend. Trunking is the process of connecting your switches together and allowing them to send VLAN information between each other. We'll start off by talking about a review of that concept, as in how it actually happens, and then we'll get a little bit more in depth than the CCNA days and explore an ISL and 802.1q frame and see what is better about one or the other and why 802.1q is currently the standard. Then we'll look at native VLANs. You've probably seen on a Cisco switch at some point native VLAN mismatch. We'll talk about what that is and why we would use native VLANs today. And then, of course, we'll go into the live interface and set up a trunk between our two switches. Let's get going. So make sure we're all on the same page. Let's do a little bit of review about the foundations of trunking. The fact is this: computers have no idea what VLAN they belong to. We just finished talking about VLANs, but this is not a computer thing. You don't go to each PC and say, you are part of VLAN 3. Rather, you go to the switch and you say, that port belongs to VLAN 3. So whenever a device, let's add another computer here, let's say a device over here on VLAN 3 sends a broadcast, it comes into the switch, and inside of the switch, it says, okay, let me put a little tag on this packet, this frame, to say this belongs to VLAN 3. But before that broadcast ever gets sent out, it strips the tag off, so that when this computer gets it, it just sees it as another frame. It doesn't realize, oh, that was originally tagged as belonging to VLAN 3, because if the tag was left on, computer would drop it. It would say that's not a good packet because there's this little, tag that I don't know what that is. So when you think about trunking, trunking is just a port that leaves the tag on. I mean, think of it this way. If you go in the trunk of your car, well, maybe yours isn't as bad as mine. If you were to go into the trunk of my car, you know what you'd find? Everything. Burgers from like 2 years ago that I got stuffed into some corner and I forgot about them. Blankets, emergency kits, some tow cables, some battery charging cables, all just stuff. And there's in my trunk. I can never fit anything in there because everything's in there. And that's what this trunk does, is it passes everything. All VLAN traffic crosses that trunk, and it crosses it without removing the tag. So when this blue computer in VLAN 3 sends a broadcast, it comes out this port untagged, but moves across the trunk with the tag still on it, so that when switch B gets it, it's able to look and go, oh, that belongs to VLAN 3. Let's go ahead and remove the tag and just send it out to this blue computer down here because it's part of the same VLAN. Trunking, I think I mentioned this before, trunking is a Cisco term. No other vendor calls those links trunks. Everybody else seems to call them tagged ports, which in my opinion is a little more accurate because that's the only thing that happens is the tags are not removed when it's sent across. Now trunking is solely a layer 2 feature. This is not anything dealing with inter VLAN routing. There's no layer 3 tags that are put in place. This is all done down at the data link layer. So now we know what a trunk is. Let's talk about the two ways that we can set them up. The two tagging flavors, spelled with an OU for my friends out there in Great Britain. First one is ISL. ISL is Cisco's way of tagging a packet, or it's more accurately said, encapsulating a packet before it's sent across the trunk. Now, the way the history goes is that Cisco was one of the first vendors to the game with VLANs, and they were the first to implement VLAN technology in their switches before there was really a good industry standard language. There was 802.1q back then, but it just wasn't that good. So Cisco created their own, called ISL, and anytime you create something that's your own, it is proprietary. That only works between Cisco switches. Now, the difference between ISL and .1q is that ISL encapsulates the entire frame before it goes out of the trunk. So imagine this. You've got this VLAN 3 packet or broadcast that came in, and the Cisco switch realizes, oh, it's got to go across the trunk. So it creates a brand new header puts it on the front. A brand new trailer, puts it on the very end, and sends the frame unchanged outside of the new stuff that it just added to the front and added to the end across the trunk link to the other side. Now let's compare that to the 802.1q, which nowadays is known as a tagging solution rather than an encapsulation solution. The frame comes in, the switch says, oh, you're in VLAN 3 and you got to go across the trunk. So instead of putting on a brand new header, it just whoosh, inserts a little shim. That's what I call it anyway. A little tag right behind the source MAC address field in the header. We'll look at this a little bit more in a bit. And then just recalculates the CRC on the end of the packet to reflect that new tag that it put in there. Because of how 802.1q tags the packet, it is now considered the better method, meaning back in the day when it was first developed, it wasn't good. It was a lot of overhead. It didn't support that many features. But nowadays, it's been revised and revised to where it is just way better than ISL. And because of that, Cisco said, okay, ISL has done its job. Let's get it out of here. And they are phasing it out of all their switches. Matter of fact, if you buy a brand new 2950 switch, you don't even have the option to do ISL anymore. It just does .1q. Some of the bigger switches like a 3500 or 3750 or to 6500, those kind of switches, still support both languages, so it can kind of bridge in the legacy technology. Let me dig a little deeper into the standards and show you just how much better 802.1q is. Take a look at this. We've got ISL encapsulation, right? And as I mentioned before, we've got our Ethernet frame over here. That was the original one. It is totally unchanged. Layer 2, layer 3, all the stuff is just as it was sent originally from the PC. As it's going across the switch link or a trunk link between two switches like this, right before it's sent, the switch will slap on this 26-byte header. Now, the VLAN tag is only 16 bits. Really small, 2 bytes of information, right? Of 26 bytes. And if you were to look inside of here, you would see in a packet trace a ton of junk in that header, followed by a little 2-byte VLAN tag, and then another ton of junk right behind it. When ISL was developed, Cisco had a lot of other intentions for it. They have junk that includes like the source MAC address of the switch, destination MAC address of the other switch. There's some CDP stuff in there. There's some BPDU stuff, you know, the language that switches use to negotiate spanning tree protocol is in there. They just had a lot of intentions for ISL, and they were like, this thing is going to really be able to do a lot. But eventually, ISL evolved to just a tagging language, and we don't need all that junk, but it's still on there. It follows it up with a brand new 4-byte CRC. That's in addition to the normal CRC that's on the end of this frame. A lot of people call it the frame check sequence, but that's unchanged. It just gets encapsulated. Now let's look down here. Oh, so much better. 802.1q just slides in a little 4-byte shim. This is what I was talking about. And by the way, if you haven't heard of a shim, they're great things you get from Home Depot. They're just a little chunk of wood like this. You buy them in packs of like 20 shims, and those things are great. You know, your refrigerator that kind of rocks back and forth, you just slide a shim under it and it fixes it. That's why I call these things shim. You just slide these shims everywhere. I've got like 20 of them just sitting around my house, random places, filing cabinets. My car has a shim under it. There's all kinds of stuff. So when you're talking about shims, that's what I mean, is it kind of slides a little shim into the existing frame. It doesn't add a new header. It doesn't add a new trailer. What it does is it slides in a little 4-byte tag. Now you might be thinking, well, I thought the VLAN tag was just 2 bytes. It is. Inside of there is the VLAN information. There's your 2 bytes. There's also a 3-bit PRI value, priority value. That a lot of people call that the class of service field, or COS. That's used for quality of service markings across the trunk, and that is a very valuable field that we need. There's some other stuff in there too. It's not really junk, I would say, but you know, it ends up comprising 4 bytes total. There's some stuff in there that allows it to support token ring VLANs and things like that. But it does not add any new headers. It just, right after the original destination and source MAC address, There's the shim. And that is inserted as it goes across the trunk and removed as soon as it gets to the other side before it's sent out to the actual clients receiving those frames. Okay. So you get your trunk set up with 802.1q. It's the better tagging language. And all of a sudden, you get these messages. They're coming across your Cisco switch and they're saying native VLAN mismatch detected on port da 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 da. It just keeps happening. Native VLAN mismatch. Native VLAN mismatch. You won't have to be in Cisco long. Give it a few months of just working with switches before you're guaranteed to eventually see a message that says native VLAN mismatch. So what is the deal with the native VLAN? What does this mean? Well, this is a concept that they created for 802.1q. You won't run into this problem with ISL because there is no such thing as the native VLAN over there. Native VLANs are good if you use them correctly. Here's the idea behind the native VLAN, the way it was originally designed. Over on the left, we've got a couple computers in VLAN 15 and a computer in VLAN 1. Over on the right, we've got a switch with a couple computers in VLAN 15 and a computer in VLAN 1. And because we're talking technology of 10 years ago or so, in the middle here, we have these two switches connected through a hub. That's what this mystical device in the middle is. Now, this was a reality back then. I know you're thinking, well, we don't use hubs nowadays, or I would never use one. But this was a common reality that we had to deal with, is that switches were trunked through a hub, and maybe there were some devices on that hub. Well, these computers are sending in packets just like they always do. That's what computers do. And they're being received on the trunk links of these switches. Well, trunk links, by definition, should only send tagged packets. That's what they do, and they put their little shims in before they send it. So what's a trunk link to do when it receives an untagged packet, that's these guys, on a trunk link? That's what the native VLAN is for. It is a configuration that you can apply to a trunk port that says, if I do happen to receive an untagged packet on this link, then I will assign it automatically to VLAN blah, and that's the native VLAN. Now, when you plug in switches together and they have mismatched native VLANs, one maybe is native VLAN 10 and the other is native VLAN 1, that's where you get that message. It's going to say native VLAN mismatch on da 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 da. So that's what the native VLAN is for. Now, I know you might be thinking, well, okay, I get what a native VLAN does now. It just takes untagged packets and puts them in a VLAN. So if it was in VLAN 1, then these guys would be assigned to the same VLAN as these guys, even though they're connected to a hub in the middle of a trunk link. But Jeremy, why on earth would I put a hub in our networks nowadays? The answer is you wouldn't. But this concept has been brilliantly applied to voice over IP. Here's the world. We've got the switch now able to connect to a phone, right? And the phone has a switch port in the back of it that connects it to a computer. This is a common configuration in the voice over IP world because it keeps you from having to run 2 Ethernet drops to every single cubicle in your environment. I mean, you only have one for the computer. Why would I want to rewire my company to have a second for the phone? But the problem is you don't ever want your phone and your PC on the same VLAN. That's not only a huge performance concern, because if people start doing heavy file transfers or something like that in the middle of a phone call, it could end up degrading the service. But also, it is a problem with security. There's already programs out there allowing you to sniff voice packets and convert them to WAV files. So you want to separate these two devices onto separate VLANs. Maybe put VLAN 10 and VLAN 20. But how is that possible? Well, the way it works is you run kind of a small version of a trunk from that switch to the phone. Of course, you're using Cisco IP phones because they're the best. And that phone has the ability to understand and send tagged packets. So you're sitting there on the phone, right? Imagine yourself. You're talking into the phone saying, "Hi, Mom, how are you doing?" And the phone automatically, as the voice, enters that handset and sends it onto the wire. It is tagging each one of those voice packets with VLAN 10. So since this switchboard is configured as the trunk, it's saying, "Oh, great. I'll go ahead and put those packets that are tagged into VLAN 10 into VLAN 10 and send them on their way with appropriate quality of service." Now, what about the computer? Is it tagging its packets? No way. Computers can't tag packets. They don't even know what a tag is. So it's just sending packets untagged. Ah, so the trunk port is now receiving untagged packets. That sure sounds like this setup up here, where we had a hub in the middle and these computers were sending untagged packets, and it would make them a member of the native VLAN, and that's how that applies today. We use the native VLAN in this kind of situation. The computer doesn't know it's part of VLAN 20. We just set the native VLAN on the trunk to be VLAN 20, so whenever the computer sends packets that are untagged, it's received by the switch and it assigns them to the appropriate VLAN for the data computers. Isn't that cool? I love that. That's one of my favorite voice over IP topics. It really is an excellent way to separate devices even though they're plugged into the same switch port. All right, let's get into the real meat of trunking and then we'll get into the config. Cisco and just about every other vendor use a protocol that negotiates trunk links called the Dynamic Trunking Protocol, or DTP. This allows you to have multiple switches connected together that will be able to recognize each other and say, "Oh, you're a switch. Well, let's just get a trunk going on," and they'll auto-negotiate a trunk between them. Now, DTP goes against every fiber of my being. First off, because I have a rule with switches. Anything that's auto-negotiated, you ought to not use it because it causes problems. For example, if you've dealt with Cisco switches or any vendor switches for a while, you probably know about auto-negotiate speed and duplex. There's a lot of problems that happen with that. And the same thing with this, auto-negotiating trunks is just a bad idea. It's confusing, number one, but number two, it provides huge security worries and problems in a network environment. Let me explain. There's 5 different modes that you can set a port into as it deals with trunking. If you set it to access mode, you will have a diagram that looks something like this. If I were to set a port to an access port, then whatever device that's plugged into it is considered an access layer device. It is not a trunk. It can only access a single VLAN. So if I assign that port to VLAN 50, then that device is on VLAN 50. Now, what if somebody took that off and plugged in a switch? Well, no problem, because it's on VLAN 50. Every port on that switch is part of VLAN 50. It is not a trunk, and there is no way for it to become a trunk, even if the other side wanted to. The danger, in my opinion, is that every single switch, when you pull it out of the box, fresh from Cisco, is in a mode known as dynamic desirable. What that means is that this port is not a trunk necessarily, and it's not an access port necessarily, but it will negotiate with whatever you plug into the other side and either become an access port if you plug in an NPC or become a trunk if you plug in a switch. Yikes. Every port is dynamic desirable out of the box, which Cisco's intentions were good. That allows it to just work when you pull it out of the box. If you plug it into another switch, it's a trunk. If you plug it into a PC, it's an access port. But here's the problem. What if somebody in their cubicle decides to pull out a Cisco switch and they're like, "Hey, let's just plug it in and see what happens"? Well, if they plug it into their cubicle wall, it then becomes a trunk link, allowing them to assign whatever ports they have on that switch to whatever VLAN your organization has. So that totally undermines all securities that VLANs provide. They can just add themselves to the server VLAN and have direct access to the servers without any sort of access list or firewall between them. That is an enormous security violation. So let me first off show you this. I want to show you how you can determine what mode the port is in on a switch. I'm sitting on a switch right here. I'm going to get into privilege mode and I'll do a show CDP neighbors. And you can see that I've got this switch which is connected to a whole bunch of Catalyst 2950 switches. Now you might be saying, well, Jeremy, do you need that many switches for this? No, I just wanted to hook them all up because it's kind of fun and I had to upgrade the iOS on them anyway, so why not? So if I wanted to view what mode will say this port is in on my switch, which is connected to another switch, I can type in show interface fast Ethernet 0/21, and you follow that up with the command switch port. Not many people know about that little modifier there. And when you hit enter, you'll see the administrative mode that it's in. That's what you've set it to as an administrator, which by default is dynamic desirable. And then operational mode will tell you what it's negotiated with the other side. Right now, I've got it connected to another switch, so it negotiated a trunk port. That's the danger. So you can see that if we hard code them as access ports, they will only belong to one VLAN, and that is what I highly recommend you do for every switch port that connects to a PC or a router or anything that's not going to be a trunk. If we leave it as the default, it will be set to dynamic desirable, which means it will dynamically change modes and it desires to be a trunk. Now, what if it's set to dynamic auto? What that means is it will automatically change between a trunk port or an access port, but it's not going to try to be a trunk. Meaning, it's not going to send any DTP packets saying, please make me a trunk. So what that means is if you, have both sides set to auto on a switch, they will not become a trunk together. And that to me is why this is just confusing. Dynamic desirable means that they desire to be a trunk and they will be a trunk if they detect another switch attached. But if they're auto on both sides, then that means neither one is going to send a packet saying, I'd like to be a trunk, so they'll both stay as access ports. So what does that mean if one side is auto and the other side is desirable? Well, if that's the case, it will become a trunk because this side will say, I'd like to be a trunk. And since this is set to auto, it will say, oh, well, I'm in auto, so I'll be a, holy cow, I just threw my pen across the room. It says, I will be auto with you. Or I will be a trunk with you. So it will negotiate a trunk with the other side, and that will end up being a trunk. So what's the trunk mode then, right? Well, with all of these different modes, trunk is where it will be a trunk. It is set, I am trunking, I am set to on. If a computer plugs in, I will not be able to communicate with it because I am a trunk and I am set to on. And here's the big difference. I am sending DTP packets, meaning I am a trunk, I am set to on, and I will tell the other side I want to be a trunk. So if it's set to auto, if it's set to desirable, if it's set to trunk, it doesn't matter. We will become a trunk. So if you set it to trunk mode, and the other side is any one of those, it will become a trunk. The last one is non-negotiate. Non-negotiate is where you've set it to be a trunk and it will not send out DTP packets. In my opinion, that is the most efficient mode that you want to put it in because you want, and remember, auto not use it, don't use auto negotiate, auto equals bad. I would recommend you set these to be trunk non-negotiate. That means that you know exactly where your other switches are attached. That means if you've got a switch and you do a show CDP neighbors, let me hit the up arrow, you can see this is a switch, this is a switch, this, you can go down that list and determine exactly what your switch ports are. You hard code them to be trunk ports and then you set them to non-negotiate so you don't waste any overhead by sending out these DTP packets. Likewise, the other reason I prefer, and I should also mention Cisco prefers the non-negotiate mode, is if somebody were to mistakenly, and let me go, plug in a computer into that trunk port, The switch is not going to send DTP packets to the computer because guess what? DTP can be spoofed. The dynamic trunking protocol, you can engineer a packet. If you're a malicious intruder and you plug into a port that's set to trunk mode, all you need to do is open your packet sniffer, Ethereal or something like that, and see that DTP packets are being sent. And you go, aha, DTP packets are being sent. Let me go ahead and set mine to mirror those DTP packets, and your computer can start trying to emulate those and negotiate a trunk with the other side, and it's only a matter of time before somebody hacks into the network. So non-negotiate is the most secure and the most, I guess you could say, solid way to do this because you know exactly what ports are set to trunking, and only those ports will negotiate a trunk. The difficulty of trunks is mainly in the concepts because they're really not too bad to configure. Let's set up a trunk. I'm going to do my show CDP neighbors again just to show you the different devices that I have. The first one I want to set it up on is a 3550 because you'll see the config is slightly different than the 2950 that I'm sitting on right now. The reason why is because the 3550 supports both ISL and 802.1q. So let me just telnet over to the 3550, and I can see the 3550 is connected to me, this switch that I was on right here, on its fast Ethernet 0/15. So let's get in there. Fast Ethernet 0/15. What I'm going to do is type in switch port trunk encapsulation, and then you get to choose what kind of encapsulation would you like to use. And you can see that I have .1q and ISL at my disposal. You can also negotiate the encapsulation with the other side, but again, you auto not do that. So I'm going to type in .1q, which is the 802.1q standard. Once I do that, I can then type in switch port mode and then follow that up with trunk. As soon as I do that, it is now hard-coded to be a trunk unconditionally. Now remember, that will start sending the DTP packets. It will still try to negotiate it with the other side if it is in an auto sort of mode, but the trunk is hard-coded. And the good news about that is if I plug in a PC, it's not going to work. This means it is dedicated to go to a switch. You can also see some of the other ones, like an access port. That's how you set it to be an access port. Dynamic, which dynamically negotiates. That's our dynamic desirable or dynamic auto that we can set up on our switch with the other side. And then we have the trunk. So those are all of our options except for the non-negotiate. I haven't set that yet. Now you can see I'm hesitating on actually typing that command in, and the reason why is I'm actually telnetted to the 3550, so I don't want to set it from that side because I'll lose my telnet connection. But I do want to set up the trunk on this side. I am on the 2950 switch, which is connected to that 3550 on fast Ethernet 024. Now that I showed you the one minor difference between those two, let's get into that interface. And let me first off show you. I'll type in switch port trunk and hit the question mark. Notice there is no encapsulation command like I typed in right there, switch port trunk encapsulation, because the 2950 only supports 802.1q. So when I want to enable the trunking on this switch, I just type in switch port mode trunk. Enter. That's all I have to do if I don't want to do the non-negotiate. You can see that the other side went down and went up. It will bounce the interface when you configure the trunking mode. Now, the other side is set to the default, which is dynamic desirable. So this did negotiate a trunk with the other side because the switch port mode trunk still sends the DTP packets. The one mode that I haven't showed you yet is the non-negotiate. And the way we do that is we type in switch port, and it's just a command right after that, non-negotiate, which says this will not engage in the negotiation protocol in this interface. Enter. At that point, it stops sending the DTP packets to the other side. So if you have one of the auto modes configured on the other side, it's not going to work. It's not going to be able to negotiate a trunk relationship. So my point in saying this is if you choose to do non-negotiate, you have to do it everywhere on all your switch connections. Native VLAN, let's talk about that. I'm going to type in switch port trunk, and you can see one of my options is native. Native will set the native VLAN that this interface will belong to. So whenever it says when it's in trunking mode, it says when I'm receiving an untagged packet on this port, I will assign it to blah. Go ahead and type your VLAN right there, and that will hard code the native VLAN for this interface if it were to receive untagged packets. So let's see. I saw the encapsulation I showed you, the mode, setting switch port mode trunk. I showed you the switch port non-negotiate. Oh, one more. This one is a bonus for you. A lot of times you will be in environments that you set up trunks between your switches, but you don't want all the VLANs to flow between them. Now, on other vendor switches, like I said, there is no concept of trunking. You actually have to set tagged ports. For instance, I just set up an HP switch this last weekend, and I had to go in there into the interface and say, I want to tag VLAN 10. I want to tag VLAN 20. I want to tag VLAN 30. I had to set a tag on that port for every single VLAN that I wanted to send across it. Now, for me, that was kind of annoying because I think there was 10 or 12 different VLANs I had to do that for on all these different switches. Tag this, tag that, tag this, hit the up arrow, change my argument. The trunk would have been handy because I could just say trunk them all, send them all across. But on the flip side, setting tags is kind of good because you only set the tags for VLANs that you want to flow between switches. For example, I have no switch here. Let me draw one up. If I had a switch up here and a switch down here, and the switch up here maybe had VLANs 10, 20, and 30, and the switch down here only had VLAN 30, well then there's no use in me sending or tagging VLANs 10 and 20 across that trunk port because there is no VLANs down at the bottom. This kind of leads into a discussion of VLAN pruning, but if you wanted to manually remove certain VLANs from crossing the trunk, then what I could do is I could just type in switch port trunk and follow it up with allowed. And I could say the allowed VLANs to cross that trunk, and you can just type in, using these arguments, what VLANs you want to send across. And it all depends on your environment. You want to send them all? Go ahead and send them all. If you want to send them all except, you can use that except keywords. If I don't want to send any and then just add them in individually, you can use none, and then you see where it says word. You can just type in a list, like I just want to send VLANs 10, 20, 30 across that trunk link, and it filters those out. That is in an environment where you manually control what VLANs cross what links. Again, that would be the way that I would recommend doing it versus using a concept called VLAN pruning, which we're going to talk about in just a few moments. Actually, I think we'll talk about that in the next video because I've been talking for a little while. So that is your way of pruning out manually what VLANs will cross a link. Okay, last thing I'll mention is how we can verify what we've just done. I'm going to jump back out to privilege mode. Whoops, I accidentally entered that command. By the way, this is a huge gotcha. I've been in environments where I've typed a command, I'm like, oh no, and I want to exit out. If you hit Control Z, it will execute whatever command you had typed in before the Control Z, which has devastated me in more than one case. So I'm back in privilege mode. If I want to verify this, first off, the easy way is just to do a show run interface and what one you want to see. And I can see from the running config, there's my interface and exactly the commands I've typed under it to configure the trunk. Now, I can also type in that command, show interface, and focus on the interface that I want to see and type in switch port after it. And that will show me what mode it's in. You can see administrative mode, trunk. Operational mode, trunk. So it is hard-coded to trunk over to the other side. Now, I will mention that the other side is set to dynamic. It is one of those ones that negotiates the trunk, which I've set this side to non-negotiate. So that leads to the question of why is it a trunk? I thought non-negotiate wouldn't negotiate, and they both had to be that way. Well, before I had the opportunity to type in non-negotiate, I did type in switch port mode trunk, which sent those DTP packets to the other side, and the other side said, oh, you want to be a trunk? Click, and I switched over. Now, if I were to reboot the other switch It would come up and not negotiate, meaning it would fail and end up becoming an access port, and this trunk would fail, which leads to a big point of make sure you do that non-negotiate on both sides if you want to do it. The last command isn't as handy in my opinion. It is show interface, and you can type in fast Ethernet 024 followed by trunk. And you'll be able to see right there what VLANs are allowed on the trunk. That's what we filtered it out. And what encapsulation it's using, what your native VLAN is. The reason I would say that's not as handy for me is I usually like the show run interface output to show me this. It's a little bit more concise and easy for me to quickly see. All right, a lot of good stuff about trunking. Let's hit the high points. We saw a trunk is simply a port between two switches that leaves the VLAN tag on rather than stripping it before it sends it out. The access ports are the ones that strip it so that the computers don't get confused that there's still a tag in their frame. We saw the two different flavors of tagging, ISL and 802.1q. ISL being deprecated, it's going away. Cisco's removing that from all future iOS trains. It's the older one that is in no way anywhere near as efficient as 802.1q. Just look at the size, 26 bytes versus 4. We then looked at native VLANs, and native VLANs are the concept of receiving a untagged packet on a trunked port. It's used if you have a hub in between them, which who has that, but it's primarily used for dual VLAN or multi-VLAN access ports, which is typically used in IP telephony. Last thing we did was walk through the configuration line by line and set up a trunk port between two switches. I hope this has been informative for you, and I'd like to thank you for viewing.